It's a great pleasure to introduce Andrew Tait. Andrew is from Earth Sciences New Zealand. If you're wondering what that is, it is the new PRO, the public research organisation of which NIWA has become part. Is that true, or is it a new name for NIWA?
It's a merger between GNS and NIWA.
Between GNS and NIWA. So Andrew is Chief Scientist of Climate, Atmosphere and Hazards and specialises in applications of climate data and products and climate change impacts and adaptation research. So Andrew's led research programs on climate change impacts and implications and was a lead author of the Australasia chapter of the IPCC's fifth assessment report. So please welcome Andrew Tait.
Big button working.
Try that now, Andrew. There we go.
Beautiful. Thanks very much. Yeah, this is Earth Sciences New Zealand. So you'll hear a lot more about what we do, I guess, over the next, well, from now on, essentially. I stopped referring to myself as being a chief scientist working for NIWA on the 1st of July this year. So it's a very new organisation, but it's really exciting. For a long time, we've actually been talking about how GNS science and NIWA are so complementary that we really should be together. And the fact is that, you know, what we're doing now is we're really building an organisation, a research organisation that is world leading, particularly across multi-hazard spectrum, right, from geologic to weather. I think that's really amazing. So I'm really pleased to be part of this new organisation. What I'm going to talk to you a little bit today is this concept of managing uncertainty. And I might give you 5 minutes back in your schedule because the last part of the presentation was really talking about risk assessment and adaptation planning, which we've had a nice introduction from the Commission just before morning tea. So maybe I'll just focus, if that's okay, on those first two items, just talking a little bit about updated climate projections and dealing with this beast of uncertainty and how uncertainty grows with time. So back in around about May, June this year, we published with the Ministry for the Environment all the updated climate projections for Aotearoa New Zealand. Are you all familiar with this? Did you hear about all of this? Have you looked at these data? No, great. Okay, well, no, great. You should have. Goodness me. Come on, get on with it. There goes the whole, engagement campaign, the publicity didn't work, get back to MFE on that. So, look, this is a webpage, our webpage, updated climate projections for Aotearoa. If you just Google climate projections New Zealand, you'll undoubtedly land on either the Earth Sciences webpage or the Ministry for the Environment's webpage on all of the new data, the new maps, and the new tools that are available to interrogate and explore what these new climate projections are, what they look like, based on the latest global modelling. So this is the key. So, and the Climate Change Commission in the risk assessment, obviously, are incorporating this information in that risk assessment process, understanding what the future climate looks like, what the future hazards look like, or how vulnerable we are to those hazards leads to an understanding of risk. So that's how it all works. This is kind of the starting point, if you like, behind that. It's really cool doing climate modelling, by the way. If anybody wants to change their profession and come and be a climate modeller, you get to create, eye candy like this. So this is a model that we've developed for New Zealand. We put New Zealand right in the middle, as where it should be, and the resolution of the model is tighter around New Zealand, and then it gets looser as you go out. It's called an adaptive grid, if you like, and it allows you now to see things that we could never see before, particularly in the global models, which are just far too coarse resolution. We can start seeing things like tropical cyclones in these models and watch them as they come down towards us, in fact, or even impacting other, Pacific countries. This is really, really novel work that we've been focusing on over the last 3 or 4 years and has come to fruition with these new projections. More and more the impacts, which is what we were talking about before morning tea, are coming from these extreme events. to understand what the future looks like for these types of tropical cyclones, ex-tropical cyclones. Are we going to get more of them? Are they going to track further south? Are they going to be more intense when they get here? Those are the questions that we really need to have from the science in order to inform those risk assessments. And we've taken leaps and bounds in the modelling to get to these types of information that can be used now. So really cool stuff. Now, in terms of data that you can get hold of, if you go to, again, MFE, just Google climate projections or climate data, you'll eventually find your way to this online map. It's a GIS-based map that you can scroll around the country, zoom, pan, etc. And there's a menu on the side of the different types of climate change variables, from changes in hot days to frost days to growing degree days to changes in intense rainfall to changes in wind, etc. You can get all of this information displayed on a map, and then you can click on a point on the map and get that little bubble or dialogue thing come up and give you the information. Or you can actually, if you're into it and your business or your organization has got GIS capability, like you use geographic information systems to overlay various layers like assets, etc., you can download the data and include it in your own systems as well to do more bespoke type of assessment. You can also change, of course, and this maybe leads into this concept of uncertainty. You can change which climate change scenario you're interested in. And it was mentioned earlier, 2 climate change scenarios. One is a sort of more moderate emissions, and one is a high emissions scenario. We've actually got 3 here. You can change which future period you're looking at. You can also change which base period you're using. So there's lots of options in this tool for doing quite a lot of exploration of these types of future climate projections. And then, like I said, if you're right into it and you want to get into the data side, you can download these data files and put them into your own GIS. And a lot of people have already done that. Did that? Oh, no, yeah, okay. I wanted to talk to you also about 2 other elements of data that are available. And one is sea level rise. In particular, sea level rise doesn't really, it's not as impactful until you think about what happens when you have a storm, right? Again, thinking about the extreme events. So this is a scenario where you've got a storm surge. So a storm surge is a low pressure system that's coming towards New Zealand. It actually the water is being blown onto the land, and it also, the sea level rises as a function of the low pressure. So you've got this kind of surge of water that can then get blown onto the land, and you can get inundated coastal areas as a result. The issue is that we already are exposed to these types of coastal inundations, and here's sort of depths, if you like, of duration of coastal inundation for Mission Bay in Auckland. But when you start to add increments of sea level rise, and I like the reference before to every degree of warming leads to more impact, it's the same with sea level rise. You can't think about, what might happen with 2 meters of sea level rise. You've got to be thinking about what happens with 10 centimeters, 20 centimeters, 30 centimeters, because these are in the planning cycles now that we are dealing with, the 10 years, 20 years, 30 years type thing. And with, here's an example of just 0.8 meters of sea level rise. You can see much more water depth for that same sort of coastal storm. You don't have to actually change the number of storms you get, because with a sea level rise, the same storm will lead to more inundation. So you can get a hold of these types of this type of information also by just Googling, sea level rise projections, and you'll find your way to Earth Sciences webpage where you can again zoom around and have a look and play with a tool. The third thing I want to focus on is really new. I don't know, you may have heard the Minister of Climate Change, Simon Watts, announce that we want, as Ministry for the Environment, will do a national flood map for Aotearoa, and that will include information from councils as well as national information. So that was really, really cool to hear. He announced that just last month. In the meantime, we've had a 5-year piece of research to develop what we consider being that nationally consistent flood inundation layer that would be part of that national flood map, if you like. and it's really detailed. So here's Kaitaia under current climate. This is a 100-year flood scenario. So what you'd expect in terms of the colours of the depths up to 2 metres and the extent of flooding. What we've also done is say, okay, what happens if we have got 1 degree of warming, 2 degrees of warming, or 3 degrees of warming? Now I'll just go back because you can see that with each one of those increments of warming, the flood extent and depths increase. That is, so this is what we need to be thinking about in terms of, where we build, the protection systems we have, what we can grow in flood sensitive areas. And again, this sort of information is about the hazard, and the hazard is really critical to understanding the risk. We put out this actually from that flood data set. You can then start to go, well, how much of our population is exposed to flooding, how many buildings are exposed to flooding, roads, etc., under different degrees of warming. So that information is really critical too from a all of New Zealand government perspective in terms of what is our kind of a national exposure to these types of events. Now, I've still got a couple of minutes, have I? Yeah, so let me just talk about uncertainty growing with time, because those of you who have already played around in the climate change space, thinking about maybe adaptation or even thinking about disclosing your risks, will inevitably have come across the fact that we don't know what the future is, right? It would be so much easier if we did, but we don't, because we could be on a future path where all the nations of the world are adhering to their commitments under things like, the Paris Accord, right? And reducing greenhouse gases significantly to a point where future warming is on a low or a moderate pathway. And that might be something like the sustainability pathway. So here's the kind of the rocky road we've been on already in terms of temperature rise. It could actually be something that's quite, flat from here on. Or it could be something that's quite different, right? The scenario is that future greenhouse gas emissions continue to be high or even accelerate. And that means that we could be on a very much different pathway of fossil fuel development or, regional rivalry, etc. So scenarios of the future based on, I guess, the way that the world behaves are then translated into emissions of greenhouse gases, and then that's then translated into future climate change. We can't not deal with scenarios, and it just makes your lives really tough, right? Because you go, tell me what the future is going to be, and I say, well, it could be this or it could be this. We're in this space, and what happens is then this leads to uncertainty, right? So these are sea level rise projections for New Zealand, and getting out to around about here, and then the projections for different scenarios grow with time. And a common reaction to this type of graph is, I can't deal with this. Am I going to be here or am I going to be here? And so you throw your hands up and kind of go, oh, what do I do? I can't make a decision based on that sort of level of uncertainty. And you see it with temperature as well. That's sea level rise. These are temperature projections for New Zealand based on different scenarios again. And you can absolutely see how by the end of the century, the range of temperature projections for New Zealand has just, it grows with time to a point where you're going, well, 1 degree I could probably manage, but are you telling me it could be between 1 and like 4 or even 5 degrees warmer than now? Give me the answer. And I say, I can't, because it's all based on scenarios, right? But how do you manage uncertainty? That's the real point, right? So one thing you can do is look at that plot and go, hang on, let's just focus on the near term, right? Not even really the near term. It's like, let's focus on a 30-year period, right? When you think about this is going all the way up to the end of the century, block out of your mind to a certain degree all of that stuff and focus in on here. And then look at the range that you get. And you're now in a space where that uncertainty is reduced it doesn't really matter which of these emission scenarios is being followed. You're basically going that much, right, in that time. Now, I'm not saying completely ignore what's happening out here, because things like long-lived infrastructure, you really do need to have an eye for that longer term. But there's a lot of stuff that you can be doing in the planning and adaptation space with a window of about 30 years. Now, the question, I guess, that comes next is, okay, but what happens when I get to here? I'm already now in the same sort of problem space that I was before. But I've got a solution, and that is that in about 7 or so years' time, there will be another assessment of climate change, the next, IPCC assessment number 7, and it will have another suite of global climate change model predictions, and Earth Sciences, if we get some funding from Ministry for the Environment, will do the downscaling again, and you'll have another set of data to work with. And so then you will have kind of a reset and another period of relative certainty in terms of where the climate is going. And you can continue kind of thinking about climate change in that type of way. It has its limitations, particularly when you're having to make decisions that are going to be really, really critical for that really long term. Big infrastructure decisions, should I build something, right? But a lot of their decision making, particularly around how we grow, where we grow things, how we grow things, what things we do grow, and how we manage operational systems like food safety systems, can actually be quite easily managed in that sort of time span. So I would encourage you to not throw up your hands and go, I don't know what I'm possibly going to do with all of that uncertainty at the end of the century. It's your future selves or your future colleagues' problem, right? At the moment, just think more in that near term, and then you can actually start to make, informed decisions about how to deal with the changing climate. And look, I can just cut this off here, because this is really what we've heard about before. The mechanisms for then thinking through these climate impacts and the hazards are there for you already. Risk assessment and adaptation planning. And there's plenty of really good examples and guides about how to do even your own local risk assessment, let alone getting information from a national risk assessment and national adaptation plans. And there are plenty of people out there that can certainly help you go through these processes as well. So maybe I'll leave it there and give you maybe a couple minutes back. Kia ora.